So just for fun, let's just practice one more time, and then we're going to go on and talk about more stuff because that's our job. Let's say I have this. Okay, so what's the total differential of this? Well, that's going to be dz dx plus partial of z with respect to y dy, right? So that's going to be 4x cubed plus 8y dx plus, that's right, 8y plus 9y squared, 8x, sorry, that's x. See, that's why we need to do these things live, because then you can yell at me and you get the great joy of yelling at me. It's no good to yell at me if I'm not there to be yelled at. Okay, so now this again is what happens to z when there's a change in x. And this part is what happens to z when there's a change in y. And notice that both x and y have an effect on z, regardless of whether it's just x changing or just y changing. Do we see that? If x changes, how z is affected depends on the values of both x and y. And if y changes, how z changes is a function of both both the value of x and the value of y. Okay? So again, there's a story to tell and there's stuff to go do here. Okay. Now, mind you, it's not that exciting yet with all that, and it should get more exciting later. I'm more, well, understanding chapter 7 is probably more important than understanding chapter 8. But when we get into more advanced math, when you start going off to graduate school, then the stuff that's in chapter 8 is probably more important than the stuff that's in chapter 7. But you got to solve the problems in chapter 8, you have to fully understand what's going on in chapter 7. You have to know the rules of differentiation. You have to be able to take your partials and do all that. All right? So we also have something called the implicit function theorem. And the implicit function theorem is very exciting. Okay? Let's suppose we have this function here, y equals 4x. Okay? Do we like that? Okay. I could also write that function out as, well, that's y is a function of x, right? I can also write that function out as y minus 4x equals 0. Right? So I can say y minus this f of x equals 0. Now you're saying, why would I want to do that? Well, I wouldn't. But there are times when we get an equation, that really we can't solve. You want to solve the equation for y, right? To do normal, taking a derivative, the way we've been learning to take a derivative, I need to be able to solve these equations for y. I need one thing on the left and everything else on the right. Well, what if I can't do that? What if I have one of these equations that's funky and there's no easy way to get that y all by itself, or I have x and a y and I need to get a z all by something. I need to get something all by itself and I can't do it. Okay? Now, this is called an explicit function because y is explicitly defined as a function of x. This one is called that's an implicit function because y and x are related, but it's not written in a way that y is clearly a function of x. Okay? Okay, fine. So dy dx, it turns out, is the minus of the partial with respect to x over the partial with respect to y. You're like, really? What the? So let's go back. Let's go back. Y equals 4x. dy dx equals 4, yes? We all know that? Okay. Y minus 4x equals 0. Same equation, yes? But now let's use that baby. So I need the partial of, yes, of this equation with respect, I need f of x, which is the partial of this with respect to x, which is minus 4, and the partial of this with respect to y, which is 1. Do we all agree? The partial of that with respect to x, or the partial of that with respect to y. Okay? Either way. What I get when I do that? Well, now I stick that into this equation. So I get dy dx equals minus 4 over 1 is 4. And yes, it took me 3 times as long to do it that way. But this is a simple example. Okay? A simple example. A simple example? Okay. So let's suppose we have 3x to the 4th minus 7, y to the 5th equals 86. You do not want to try to solve that baby for y. It will make you unhappy. It's not that you couldn't, but darn it. Yeah? Well, really, because you'd get y to the 5th equals blah, 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 and that's why to get that down, you'd have to divide that by y to the 4th. You're just not solving this, okay? Using regular math. But I don't need to solve it using regular math. I can solve it using the implicit function theorem. Because, yay! I am an advanced economics student now, and I know my implicit function theorem. I was born and raised on my implicit function theorem. Okay? So I'm going to take this baby. Yes? I'm going to find f of x, right? Which is the partial of 3x over minus 7y to x. Or f of y, which would be the partial of this thing. Now you're saying, hey, idiot, there's an 86 there. I don't care. Why don't I care about the 86? Because the derivative of that 86 is always going to be 0. I could move the 86 over to this side. I could move this over to this side of the equation and put a 0 here if I wanted to, right? We'll talk about that in a second. I could do that, but I'm not gonna do that. Okay? So what's this equal to? That's equal to 12x cubed, yes? I believe. And what's this one equal to? This is minus 35y to the 4th. Okay? So again, I have this equation. I could make this. But that's just going to always drop out of the equation anyhow because it's 0, right? The partial of 86 with respect to anything is going to be 0. And then I know dy dx equals minus f of x over f of y is minus 12x cubed over minus 35y to the fourth is 12x cubed over 35y to the fourth. And that is, yes, dy dx for that equation. Yay! So if I were to plot this thing, right, that would be the slope at any point. Any combination of y and x, that would be the slope. Now, you're saying, wait, well, some things are relations, not functions. We're not going to, you may or, yeah, all right? Just practice. It's good for you. 4x squared minus y cubed equals 97. Again, we're going to take the partial of this. We could move the 97 or not. I don't care what you do. Partial of that with respect to x, and the partial of that, that's a d looking thing, right? With respect to y, right? So the partial with respect to x, fx, equals 8x. Yes? Yes? And fy is partial of this with respect to y is minus 3y squared. And so dy dx equals minus f of x over f of y is minus 8x over minus 3y squared is 8x over 3y squared. Fun? So that's the implicit function theorem. Is that exciting? Yes, it is. Just nod your heads. Yes, that was exciting. We don't get exciting stuff like this very often. Okay. Now, let's go back to the total differential. Shall we? Which was, so something like dz equals fx dx plus fy dy. Okay? 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 Now, there's something interesting I can do with this. That you, if x and y are not independent, okay? So if we know that z is a function of x and y, but y is a function of x, now those things are not independent, right? It's like, do you remember c plus I plus g? Yes, but equals y, but c is a function of y. Yes? And if I put taxes into this, right? And I put taxes, these equations, this equation gives me y, but I got to know y to find c. So there's a, a circle thing going on.